Welcome to the shop. In today's video, I'm going to be introducing the first production unit of Octavius Squeezer. The Squeezer has been under development for quite a long time, and I've made a number of videos showing the various prototypes along the way, but now it's been developed to the point where I'm confident that I can release them out into the wild and see what customers can do with them. So here it is, version 1.0, serial number 1, first production unit of Octavius Squeezer. Let's start off at the top of the unit, where I'm going to show the chain drive system. You see that we've got a bunch of roller chains and a bunch of little idler sprockets, and kind of hard to do while filming or videoing, but here's the operation. And then moving down to the bottom, looking now at the puller assembly under the top plate, we can see how the chains are pulled, and you notice that they're pulled by a steel rod attached to a plate, and the steel rod is guided by bronze bushings, and this pretty much guarantees that the plate will be perpendicular to the base and pull all of the chains in an equal amount. In previous versions of the design, everything was screwed together and welded together, and this made it kind of unwieldy and difficult to ship. It would have required strapping to a pallet and shipping by truck freight. So in this design, in order to make it shippable by UPS, I've included some assembly plates that can be removed with a few screws, so the foot assembly comes off. And then if you look up in the top, the entire head assembly can come off. And it's a fairly simple disassembly involving just a handful of screws that can be operated with normal hex drivers. The Squeezer is a modular design. This means that it can be used in a variety of different configurations, some of which I've already invented, some of which, who knows, maybe somebody else will think of something cool, or I'll think of something cool. I don't know. But at the moment, there are two different configurations for the Squeezer, the fixed dies and the iris dies. Now, all of these configurations do share one thing in common, and that is quick disconnect. So here is a fixed die support bracket, and you see it goes over the locating pins pretty much effortlessly and then is clamped in place. The earlier versions of the Squeezer, in order to change from one set of dies to another, things had to be unscrewed, and it was a calibration process, and now it's a lot faster and a lot easier. So all of the dies and their supports are configurable and interchangeable using quick disconnect action. The fixed dies themselves are also modular and quick disconnect. Here's an example. Hopefully I can get that in the camera, showing that each size is engraved with its dimension in inches, and the dies fit, once again with a quick disconnect action, fit onto the die supports. This makes changing sizes of fixed dies very quick, since the fixed size dies only squeeze one particular size. So if you're making a, in this case would be a hexagon with each side being 1 1/8", you'd use the 1 1/8" squeezing dies. If you want to go smaller, you have to change the dies. This is both a disadvantage and an advantage. The disadvantage is you need a special set of dies for each size you're squeezing. The advantage is that the motion is pretty much straight toward the center with no sliding against the glass and no introduction of distortion. Of course, as I'm making this video, I realize that I forgot to include the center support. This center support is something that you can press the glass against while squeezing, and this will give a flat bottom, and in some cases can actually produce a very nice shape with nice sides, nice corners, and a nice bottom with fairly close to sharp corners. So might as well do a couple of squeezes here. And in addition to the flat dies, a variety of different shape dies can be used. And even though I haven't done it yet, there's always the possibility of doing segmented blow-in molds where you can make a mold with maybe deep undercuts or some other complex shape that can't be done in a traditional fashion, the way blow-in molds have been done for centuries. If you have deep undercuts, there's no way to get the glass piece out once you blow into it, especially if you're blowing boro, which tends to freeze as soon as it hits the hard die surfaces. So if the blow-in mold was attached, a segmented blow-in mold was attached to the fixed supports, and that there's a variety of different ways you could do that. You could do a two-sided, three-sided, four-sided, depending on the complexity and how much work you wanted to put into making the blow-in molds. You could blow into a fairly complex shape with deep undercuts with the squeezer in the closed position, then allow the dies to open and pull your finished piece out. Iris style dies are another type of die that can be used in the squeezer, and they have a fairly complex and tricky geometry that took a little bit of work to figure out. They also have a quick disconnect mount, just like the fixed dies, and can be installed pretty quickly. And sometimes this is important when you're doing glasswork and you got a piece that's getting cold and you want to make a change right away, or you're just hot to trot to get the job done. So quick disconnect, everything slides over the pins and clamps down with the little toggle clamp. And get around to the side here. So here's how the iris dies move. And as you can see, it's a fairly tricky geometry that was not at all straightforward to figure out. The advantage of the iris style dies is that they can squeeze any size. You don't need a specific 1-inch, 2-inch, 3-inch set of iris dies. There's only one size, and it basically one size fits all. The disadvantage of the iris dies is that because of the way their geometry works, the graphite is sliding against the glass workpiece. Now, this can be potentially a problem, or not a problem, or halfway a problem, or maybe not a problem at all. So sliding the die across the glass surface can cause the glass to grab and twist and introduce some interesting effects. Part of the fun of glasswork in some cases is seeing how the glass reacts and being surprised, often pleasantly, by how the glass moves in a process. And I've had success in some cases just putting the glass in, using the iris die, and let the glass flow the way the glass flows, and the distortion turns out to be kind of cool. Another strategy that you can try if you want to minimize the distortion is to put the piece into the iris dies, barely touch the surface with the die, causing the surface to solidify, and then apply your full squeezing force, and this minimizes the amount of distortion. Of course, if you're squeezing something like a bullseye or some other pattern, some other solid pattern or hollow pattern where it doesn't matter, where you're not doing some sort of a complex mourini with some sort of complex inner shape that you want to keep all under control, then it doesn't matter if it slides a little bit. So once again, both die sets have advantages and disadvantages. The iris, one size fits all, but it slides. The fixed moves perfectly toward the center, produces no distortion, but you need a separate size for each piece that you're making. The standard fixed dies that I make for the squeezer are available in sizes ranging from 5/8 inch to 2 inch in 1/8 inch increments. And this is shown on the website in the price list, where each set of dies and individual die is priced separately. And of course, I kind of got ahead of myself a little bit. That pricing is done starting with the base unit and then a menu of options, since all buyers may not want all configurations. So that's pretty much it for just showing the machine in my office here. Next, I'm going to be showing some snippets that I've made, not on this machine, of course, because this one is the very first production unit, but I have a number of video snippets that I've made over the years showing how previous prototypes have been used for glasswork. So once again, thank you for watching, and Octavius Squeezer, first production release. So before getting into the glassworking demos, it's probably a good idea to say that the project has a website, and the name is fairly straightforward, octaviussqueezer.com. It does have a hyphen in it, which is somewhat uncommon in the world of URLs for websites, but oh well, that's what it is. The website contains a lot of pretty pictures showing the machine in its various configurations, and also contains a price list showing the prices for the base unit and all of the available options. So here's some of the pretty pictures, starting off with the unit in its fixed die configuration. Here's a close-up of the logo. Gotta have a logo. I like logos. Here's the 6-axis fixed die configuration, the 4-axis fixed die configuration, the 3-axis fixed die configuration, and the 2-axis fixed die configuration. Now there's also some specials, and the specials are still a work in progress. There aren't that many of them, but as time goes on, there will be more. And I'm hoping that if the project is successful, that other makers, other tool makers, other graphite tool designers come up with ideas for their own custom versions. Here's one that's kind of like a metalworking tool called a press brake, used for bending flat glass. Here's one used to make a kind of a triangle-y kind of shape with curved sides that can be used to make a pattern commonly called a sacred geometry. Here's one that can push grooves into the side of a piece. And finally, here's the iris dies, starting with the 6-sided iris, which is shown in the previous video snippet, the 4-sided iris, and the 3-sided iris. So now, here's some selected video snippets from my full-length YouTube videos showing the squeezer in action doing glasswork. If you're interested in seeing how the entire process proceeds, the full videos are available on the channel, and there are many of them. I'm starting off the video demonstrations with a mourini assembly. I'm doing cold assembly of components that I made previously, putting the pieces into an assembly fixture, wrapping them with stainless wire to keep them together, putting them in the kiln for preheating, then torching the end and taking a pre-made punty and sticking on the back end so that I can handle it. After welding the ends together so that they don't fly apart, I cut the wire and heat using both the inquala and handwork, and then squeeze. The first squeeze just kind of consolidates the pieces together and gets them to tag, and then the process repeats, heating, squeezing, heating, squeezing, until finally the desired shape is achieved. I use a combination of inquala and handwork for the heating and squeezing operation. After the assembly is done, I pull the piece as well as I can, and unfortunately I'm not the world's greatest puller, so the pull sometimes comes out a little bit uneven. Well, this isn't the problem. The squeezer can fix it. So I go out to, after annealing, I go out to the cold saw, cut the pull into sections, put them in the kiln, stick them on a punty, slowly heat them, and then using the fixed dies in the final size that I want to achieve, incrementally squeeze, and heat until finally I've achieved a very nice, uniform, square section with nice sharp corners and a nice flat bottom. In this next video snippet, I'm assembling what's going to be a triangular piece out of flat components that were made previously. I kind of weld them together into what starts out as a flat bar, then put them in the squeezer and gently coerce the flat bar into triangle shape, producing a kind of a fun distortion at the same time that adds to the design. So I squeeze, weld on another piece, squeeze, weld on another piece, repeat until I've finally formed the whole thing together into a nice triangle. Then I switch to the special fixed squeezing dies to push a groove into the side of the triangle piece, and after the groove is pushed in, you can see here in the picture what the piece looks like. After the groove is pushed in, I weld some other components into the groove and then squeeze the whole thing together into a triangle, which is then pulled, cut into slices, resized, and then assembled into a hexagonal final result. Glassworkers have been squeezing glass for a long time using a variety of simple tools, including things like arbor presses. The real strength of the squeezer comes in squeezing the odd shapes like triangles and hexagons, but of course it can do the simple things too, like two-sided squeezing. Here I'm using the two-sided squeezer to take a simple round cylindrical shape and squeeze it into a flat form, which will then be pulled into a flat bar. In this section, I'm going to be assembling a piece out of a bunch of flat bars. Because the assembly starts out in a kind of an uneven shape, and I add stuff as I'm going and don't want to have to keep changing fixed dies from one size to another, I'm using the four-sided iris dies. For this pattern, I don't really care if there's a little bit of distortion because of the way the geometry is done. I don't tend to get distortion sticking flat pieces together. That's probably enough for a quick overview to show what the squeezer can do. If you'd like to see more full-length videos, be sure to look at the rest of the videos on the YouTube channel. And if you're interested in the squeezer, be sure to go to the website and contact me, and we'll see what we can do. As always, thanks for watching. It's been fun.